The good news about 8.1, this is where we learned about inverse variation, is inverse variation is the only one that uses division. So only variation that uses division. Yesterday we found out that direct variation is multiplication, y equals kx. And inverse is always going to be the division, y equals k over x. But we have more of these variations to talk about today because it says recognize and use inverse variation, but also we're going to talk about joint and other variations today. So that tells me this. If the only one that uses division is inverse variation, well, the rest of them must be multiplication. So no matter what name they give it, what fancy name it is, as long as we keep our eye out for inverse variation being division, we're going to be just fine. So that brought us to this page. And geometry formulas are kind of famous for being direct and inverse variation and that kind of thing. So perimeter of a square. The perimeter of a square is 4 times the length of each side. Well, that's definitely direct variation. It's 4 for our constant of variation, y equals kx. Volume of a cone. One-third area of the base times the height. Well, it's multiplication, but until today, we don't know a name for that, because it's more than one thing. Direct variation is, hey, here's the constant of variation, and you're multiplying that times something. That's direct. Today, we find out that's called joint variation. So the word variation tells us we've got to have a constant of variation in our answer somewhere. There has to be a k in there somewhere. And we just need to, as I mentioned before, watch for inverse and know that that's division. All the others are going to be multiplication. When one quantity varies with respect to 2 or more quantities, then we have what's called a combined variation. So some of them could be multiplying, but they could also throw in an inversely in there, which would mean that we have to divide. When one quantity varies directly with 2 or more quantities, well, then it's not called direct variation anymore because direct variation is just kx. This would be called joint variation. So basically, joint variation is multiplication of more stuff. That's what it is. And we keep our eye out for inverse so that we know that we have to divide. The volume of a cone varies jointly with the area of the base and the height of the cone. And in this case, k is 1/3. And that formula was something that was given to you in geometry. But it definitely is joint variation because it was 1/3 area of the base times the height. So these two variables here instead of one variable make it joint instead of direct variation. So down here, combined variations. Reading these words, this is what we should be writing. Z varies. That tells me I have to have a k. Z equals k. Jointly, that's multiplication. Multiplied by what? With x and y. xy. So again, we just keep our eyes open for inversely because inversely tells us we have to divide. The second one says z varies, so immediately z equals k. Varies jointly with x and y, that's multiplication, times xy. Inversely, oh, I stopped. That's division. Divide by what? W. And there it is. Z varies directly. Well, varies, I'd stop right there. Z equals k. Directly with x, so I have to multiply it by x. And inversely, so it's telling me here's the stuff to divide by, the product of WI. Product is multiply, so we're supposed to put that little WI that's multiplied together on the bottom. Which word are we going to watch for to know we have to divide? Exactly. Everything else that we're going to learn about for variation is multiplication. So now, they're going to start giving us some word problem-y things. They are, but they aren't. You know, we just have to watch out and remember, okay, if it says variation, I need a K. And then if it says inversely, I have to divide, but everything else is multiply. The number of bags of grass seed, N, needed to reseed a yard varies. Uh-oh, I'm going to stop right there. If it's variation, I need a K. N equals K. Varies directly with the area A. Directly, is that multiplication or division? Varies directly with the area A to be seeded, and inversely, what does that mean? Inversely with the weight W of a bag of seed. Now they're going to give us some numbers because we need to figure out what K is. So if it takes 2 3-pound bags to seed an area of 3,600 square feet, well, we better figure that out first before we try to answer their question. How many 3-pound bags will seed 9,000 square feet? All right, so 2 bags. The number of bags is N. I don't know K. Still looking for it. A is the area to be seeded. They told us that was 3,600. W is the weight of the bag of seed. Well, the weight was 3 pounds. Hey, 3,600 is divisible by 3. That's 1,200. And now if we just divide both sides by 1,200, we can figure out what K is. A not so beautiful 1/600th. But we needed that because this formula doesn't have enough information. K is supposed to be a number. Now we know what that number is. So we're going to put this right back here. So N equals 1/600A divided by W. And I need that because they asked me a question about it afterwards. How many, okay, so we're supposed to find N, how many 3-pound bags, all right, well now I have to figure out where the 3 goes again. Where's it go? Bottom, W. Seeds 9,000 square feet. Where's the 9,000 go? Well, now it's calculator time. So we need 1/600 times 9,000. Enter. Divide it by 3. 5 bags. Now, if you wanted to punch that in all at once, remember, if you have more than one term on the top or the bottom of a fraction, you have to use parentheses. So we would need parentheses up here if we wanted to punch it in all at one time without having to stop and hit enter. But there it is, it's 5 bags. Now, if we'd have looked at this problem without knowing the names that direct was multiplication, that joint was multiplication, and inverse was division, this would have been tough. But we do know those things now, so this is not bad at all. John, put the phone away. Take some notes. The number of bags of mulch you need to cover a planting area varies. Number of bags. I guess I'll use N again. Varies means there's going to be a constant of variation, so there's my K. Varies jointly. Jointly. Is that multiplication or is that division? multiplication, with the area to be mulched A in square feet and the depth of the mulch D in feet. Oh, well, and that one's all multiplication. Okay. If you need 10 bags, so where's the 10 going to go? Which one of these variables stood for the number of bags? To mulch 120 square feet, where's 120 square feet going to go? A, because that's the area in square units. Depth of 3 inches. Where's that go? D, except, here's what we have. They said, this is too easy for you. We're going to put something in that you have to watch out for. D has to be in feet. 3 inches is not feet. It's 1/4 of a foot. So we have to put a 1/4 here. They were hoping we'd miss that. We didn't. So 1/4 of 120, that would be 120 divided by 4. What's that? 30. Let's divide both sides by 30 and reduce to get K. Well, let's write it. Let's put that K where it's supposed to go. 1/3 needs to go right there. Too many phones today. I'm going to have to start taking them away just to make my point. Pay attention. This shouldn't be hard at all, but if you don't pay attention, yeah, it's going to be. All right, so there's our formula. How many bags do you need? Okay, well, that's N. To mulch 200 square feet, where should the 200 go? To a depth of 4 inches. Okay, we can't use 1/4 anymore, right? What do we use instead for feet? 1/3. All right, so we need 1/3 times 200 times 1/3. $22.22222222 bags. And you go into Menards and you say, yeah, I'd like to get me 22.2 repeating bags of mulch, please. No, that's not going to happen. So you'll have to buy how many? Yeah. You know, they're not going to say, oh, sure, here's where all the ripped up bags are. Let's go over here and weigh this out. No, no, no. You buy a bag or you don't. Besides, you might spill a little somewhere, a little extra. Not a bad idea. All right. Now, when we mix up all these types of variations, remember they're called combined variations when we do that. But as long as we keep track of that there's only one of these to divide, which one is it? Inversely, we're totally fine. So even when it looks like a kind of scary word problem, it's not a scary word problem. Gravitational potential energy, PE, is a measure of energy, which I'm sure you did in 9th grade science class. I remember my girls doing that in 9th grade science. PE varies directly. Oh, that's what I was waiting for. It varies. So PE equals K. Directly with an object's mass, M. Directly. Multiplying or dividing? And its height, H. So what do I do with the H? Now this is science. They should not have said directly. We know that it should be jointly, but you know, they're science people, so they're doing the best they can. So PE varies. Directly would be multiplication with M and H. Physicists use G to represent the constant of variation. Oh, okay, so we won't use K. we'll use G so we can be physicists. The skateboarder in the photo. Well, better get that up here where we can see everything. The skateboarder in the photo. There's the skateboarder in the photo. Has a mass of 58 kilograms. Oh, where's that go? And a potential energy of 2,273.6 joules. Where does that go? PE. What is the gravitational potential energy of the 65 kilogram skateboarder on the half pipe shown? Well, we're missing something. We're missing H. It's in the picture. Yeah, we have to look at the picture. H is, it said, right up there, height in meters above the ground. Oh, it's 4. So we better figure out what 58 times 4 is. And I don't want to do it in my head, so I'm going to punch it in. 232. And divide by 232. I better get that down where I can see it, otherwise I'm going to forget it. 2273.6 divided by 232. 9.8. That sounds suspiciously like something we should already know. Yeah, that's your gravity piece from science, in 9th grade science. I know it's been a while, but there it is. But they just wanted to make sure that we know we could find it. You know, scientists make it out like it's a big deal that they know it's 9.8. We just did some 11th grade math and we got 9.8. So it's not supposed to be hard. You just have to learn about variation. So now we do. So there's G. So let's plug it in. PE equals 9.8 mH. Because we still have to answer their question. So they've got a new skateboarder, and the new skateboarder weighs 65 kilograms. But they told us they're going to do the same place, the same half pipe over here. So it's still going to be a 4. So now it's just punching it into the calculator. 9.8 times 65 times 4. 2,548 joules. And there we have it. Now, typically, I know I was thinking when I stopped at the 9.8, should we label that? Not in math, we don't, because it's the constant of variation. It's just a number we're going to put back in there. So we don't worry about the labeling in that piece. But this one, when we're actually using the formula, yeah, we want to put the joules on there. So, what else do they have for us? Oh, I love this one. I almost forgot this was on here. I substituted the picture from your book. And the reason I did that is because that is a former Elk River student right there, Laura Ryan. I had her in class, oh my gosh, it's got to be almost 10 years ago now. And she just had started diving here in Elk River. She was on the swim team, and she's like, hey, coach came up and said, we don't have enough divers. Do you want to give it a try? And after a few times, she did not immediately say, I want to dive. After a few times of being asked, she said, okay, I'll give it a try. She ended up in the Olympics, for goodness sake. Elk River diver in the Olympics. So how much potential energy would a 41 kilogram diver have to stand on a 10 meter diving platform? Well, let's see. We just had our formula. Oh, what did they use? MH. All right, so the mass this time is 41. and the diving platform height changed. What did it change to? Well, it's still just punching it in. So let's see. If they're higher, they should create more energy. 9.8 times 41, but they're not quite as heavy as the other two divers. 4,018. So that height really does make a difference, going from 4 feet to 10 feet. Now, B says, pardon me, my cough. There we go. An 80-kilogram diver. Oh my, that's the heaviest one yet, isn't it? Yeah. So we've got an 80-kilogram diver. They're going to stand on a 6-meter diving platform. At what height should a 40-kilogram diver stand to have equal potential energy? Do you need to find the potential energy of either diver to solve this and explain your reasoning? So we don't even have to solve it. They just want us to figure out if they give us that information, can we answer their question? Sure we can. It's all about being equal, right? So we'd have 9.8. Oh, shoot, I scrolled past it. I know they were heavy. Was it 80? How high was the platform? 6. So kind of halfway between, well, not even halfway, because we talked about a 4-meter and we talked about a 10-meter. And then we've got a 40-kilogram diver. So would we have to find the joules for either one of these? Yes and no, right? We probably wouldn't label it, but we'd multiply this out. We'd write the number down. We'd divide by 9.8 times 40. So the answer to their question is no. We could just use the fact that they're equal. Come on, Blue. Behave. Well, my hand is not as fast as my brain. My brain's writing the second letter instead of the first letter down at the time. So no, use the fact that they're equal. So we could find it. Let me just tell you what it is, because it'd be kind of silly. It's just watching me punch it into the calculator. It would be 12. Somebody else already got it? And that was in feet. 6 meters. And there we go. So, only one type of variation uses division. What is it? So when you read directly and jointly, what do? Yes, you got this. Let me get you day 2. Little practice. Oh my, plenty of work time, huh? Yeah, till 10:45. You can finish this. Inverse leaves division. Remember that. You can finish this one before you go. Remember, it's okay to use your phone as your calculator if you need to, because this is just going to be some basic multiplication and division stuff. But don't use it to be texting and messing around. Let's make sure everybody knows this. Then we'll have another good test for everybody.